and sharing my screen. And I'm going to start with, let me move this, just general notes exam one on sets. Last class we decided that it was available on Wednesday after class. Started till Thursday, just before midnight. The test is in My Math Lab. You're going to put your answers into My Math Lab. But what you have to realize is you've got to show me your work in Blackboard. I was just in my office hour going over quizzes with people, and I think they realize that if you show your work in Blackboard, I can give you partial credit for your work. If all I have is a wrong answer, I can't. And likewise, if all I have is right answers without supporting work, I am not going to give full credit because I know that there are things like apps out there that will give you answers without you doing anything but taking a picture of the problem. And so that is not acceptable. And so you need to show me your work for quizzes, but more so for tests. Homework 5 is that homework on surveys that we were looking at last class. The project is due a week from today, giving you 2 weekends because I'm asking you to go and talk to get information from 20 people. I'm not forcing you to go out and talk. You can do it virtually or through the phone or something like that. You know, so keep safe, social distance through all of this. What I wanted to do today was go over that practice test. Before I do so, is there anybody who wants to look at either the quiz or any of the homeworks?
The more we review, the better.
Well, let's look at that practice test. But one thing that I did want to show you that is in that paper textbook, that's also in that virtual textbook, that if I were a student, I would appreciate a lot. So I'm going to go into the multimedia library. In the multimedia library, I'm going to go to chapter 2 that we're in. I'm going to go to, I guess, the last section. I'm going to click on the textbook, find it. Then I'm going to go down and click on the textbook and open it. Has anybody made use of the virtual textbook? Is there anybody who wishes they had a in your hands paper textbook? Because if there's anybody who really feels they would do better with an in your hands paper textbook, I do have a few back editions of the book in my office that I am willing to share with people if it'll help you. But now over here, I'm going up to the menu on the side. In the menu, as I look at chapter 2 sets, you see over there, there's a chapter summary, review, and test. I'm going to click on that. And what comes up slowly is a real great chapter summary and review. And what it does is it goes through everything in the chapter and it explains what the notation is, what the definitions are, just a real one-page summary of all of the nuts and bolts. And then there's a nice set of review exercises that you can look at. And in addition to the review exercises, there's what the author of the textbook would use as a chapter test, which years ago I sort of used as a guideline for writing that first, my first chapter test. And if you want to do that pencil and paper chapter test, at the end of the book, they give you You know what? Let me, before I go through and do that. I don't think they have the answers to the chapter tests at the end of the chapter. I think they don't show up until the end of the book, but at the end of the book, yeah. At the end of the book, they give you answers to the odd number exercises, but I do believe they give you answers to all of the questions in the chapter review and chapter test. So that if you want an additional place to practice, you can look at that chapter test in the textbook. And when you go through and do it, you can see where I've got a list of answers. Yeah, they give you all of the answers to the reviews. And again,
Where's that located at? I missed it.
in the virtual textbook,
Okay.
do you know where the virtual textbook is located?
It's just this part right here. This, I got lost when you got to this page here.
Okay, do you see, I clicked menu and this menu popped up. In this menu, down at the bottom, it says answers to selected exercises.
Oh, okay. There it
And
is.
that's where you can find the answers. You have to do a little bit of paging through to get to the right section. Okay?
Okay.
And so that's just additional practice for those of you who would like it. Otherwise, I am going to go back into the OneNote and I'm going to go to that exam one review that's available in Blackboard, but it's real similar to this. This was written when I made my own pencil and paper tests. And this was actually virtually the same questions as my pencil and paper tests, just the numbers have changed. When I chose questions for my labs, for the My Labs version of the test, I tried to choose questions that were similar in nature to my pencil and paper test. So I think going over this would be a good review. After we go over it, I will upload it with the answers in it. And again, it's in that handout section of Blackboard if you want to practice it more on your own. So, shall we get started? First question asks us to give the set by roster. We want, does everybody remember set builder notation? We're looking here at the set of all X, which means I want to look at, I'm using a variable to represent what's in my set. It has to be a natural number between 3 and 9. Do I include the 3?
No.
No. So it'll be 4, 5, 6, 7, 8. Do I include the 9?
Yes.
Yes.
Yeah.
Next question asks if two are equivalent. In order to show my work for this one, what I would do is I would first list each set. Set A, again, is natural numbers. Natural numbers start with 1, 2, 3, 4. Should I include the 5 in set A?
No.
No.
Set B are the vowels. The vowels are A, E, I, O, U. I think it's clear to everybody those two sets are not equal. They have totally different elements
How did you know to add all the vowels?
because it says every element is a vowel. And so that's the set of vowels.
Okay.
Contains everything that is a vowel is what that notation says. And so now they're not equal, they're very different elements, but in order to be equivalent, they don't have to be equal, but I should be able to match them up. And so can I match everything from A with something from B? No.
No.
If I were to ask how many things are in A has 4 things. If I ask how many things are in B, it has 5. And you remember, in order to be equivalent, they have to have the same number of elements. which these do not. That one, okay.
Yeah.
The answer would be no, different cardinality. Next one, this pen is too thick today. It's for working on this. Work for this, letters in the word carpenter, C, A, R, P, E, N, T, and we've got the E and the R in there already. Letters in the word car, C, A, R. Are all of these in here? Is everything from the first set and the second set?
Yeah.
Yes.
The first set has P. Is P in the second set?
Oh,
No, they're not all in there, so it's not a subset. We're looking to see, does everything from the first one show up in this? I look at 4. C-A-R. Is C in the second set? Yeah. Is A? Yes. Is R? Yes.
Yes.
You can say it's a subset. Now, when I compare those two sets, are they the same?
No.
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 I can say that it's both a subset and a proper subset.
So that means that they have the same elements but are not equal. Is that
This one, yes.
okay?
This one says they have everything from the first one is in the second, but the two sets are not exactly the same.
Okay.
So that's when we do the C without the line underneath?
Right.
Okay.
And if you can do the C without the line underneath, then you can do the C, then you can do both of them. 5, the first one is 1, 2, 3. Second one, numbers less than 4, 1, 2, 3. What do you notice about those two sets?
the same.
They're the same. So is everybody right? I can say they're equal. And if they're equal, I can say the subset with a line underneath. Because this one says it's okay if they're equal.
Because it has the same amount and the same identical numbers.
Right.
For the test, can we write either or?
I do believe because the test is in my math lab, it'll be like the quiz. And remember the quiz had choices, this, neither, or both. And so this
Yeah.
one would be just this one. The one above it, it would be both. And so that's how my
Okay.
math lab words those questions, like the quiz did. Okay,
The number 5
Okay.
answer will be both, right?
right. The number 5 answer would be both subset and proper subset because the empty set is a subset of everything. Because remember up here, in order to not be a subset, it had to have extra stuff. The empty set has no extra stuff in it, so it's a subset of every set. Now this next one's a little bit tricky. Over here, that X, is that a set?
No.
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 And so we can't say it's a subset. Now, let's look at the set on the other side. Does everybody see the set on the other side contains one word?
Yeah.
Yeah. And so we're going to say that X is not an element. We could also say that it's not a subset because it's not a set.
Because it has a missing letter or word or whatever.
Well, in order to be a subset, it would have had to been in parentheses.
Okay.
But because this is the whole word, we're looking, the only thing that could be a subset would be the empty set or the set with that one word in it. Now, this one, we're looking at a set that has 5 letters. This is one of the letters, so it is an element. but it's not a subset. Instead, if it were in the braces, then it would be a subset. Subset we use when we compare two sets. Element we use when it's just a thing and we're wondering if that thing is in there or not. Is everybody okay with the difference between the two?
Yeah.
Next one, the first set is 1, 2, 3, 4, 5. What's in the second set? Numbers bigger than 10.
Mhm.
11, 12, 13, 14, and it just keeps on going. Are those in there? It's 1, 2, 3, 4, 5 in there?
No.
No, so it's not a subset.
Because if it did, it would have the little dots right after the 5, right?
Right. Well, no, there's, even if it had the little dots, this still doesn't include 1, 2, 3, 4, 5. So it would
Okay.
not be a subset.
Okay.
Okay. Now, on the quiz, there were some people who did their operations right, but forgot what that little n in front means. The n means the cardinality. Means how many things are in there. It's the number of elements. And so how many elements are inside set Q?
1.
Or
4.
The number of things in Q is 4.
Oh,
Because the comma in between, it's 4 letters, not one word. Now this next one, you kind of have to remember a formula for. Remember when we were looking for how many subsets, every time we added something, it doubled. And that's supposed to remind you that we need the number 2 in our formula. And it depended on how many things there were. So the formula is 2 to the n. So this would be 2 to the 4th, which is 16. And remember, if it's a proper subset, we have to take out the set itself. So we subtract 1 and get 17. Oh, Lord, what did I just say? What's 16 minus 1?
15.
15, yeah. Sorry about that.
That's okay.
And I'm sorry, my phone rang. So let's carry on. Is that page okay?
Yeah.
So we would have something like that, like all one problem right there, right?
Oh, no, this should be like a dozen different problems. Oh, this one? I can't remember if in my labs they put it all one problem or if they split it over separate problems. I have to apologize, I don't remember. List all the subsets of the set PIG. Well, how many things are in the set PIG?
3.
2, yeah, 3 things. So there should be 2 to the 3rd or 8 subsets. One subset is the set itself. One subset is the empty set. Then we could have P, we could have I, we could have G, we could have PI, we could have PG, and I think we could have IG. And I think it gives us 1, 2, 3, 4, 5, 6, 7, 8. That one, all right.
We always do an empty set.
The empty set, if we're listing all of the subsets, the empty set is a subset of every set.
Okay.
Next one asks for a Venn diagram. I have to apologize. My pen just stopped working. Give me a second. There it is. So box for the universal set. How many loops should I put in this one?
3.
3. 1 loop for A, 1 loop for B, and 1 loop for C. First place I fill in is where they overlap, what they have in common. Common to all 3 is the A. Then common to A and B, besides the A, they have the C and D. Common to B and C, they both have E. Common to A and C, the only thing that they share is the A. Then A has A, we have to add B, C, and D. B has A, I'm sorry. Oh, wow, what did I say? B doesn't have A, does it? There's nothing common to all 3.
No,
Guys, A should go over here. B has C, D, E, F. That's because I'm not wearing my glasses. C has A, E, H. And the universal set has A, B, C, D, E, F, G, and H. Now using that, A complement, does everybody remember that slash mark means what's outside of A? And outside of A would be my F, E, G, H. A union B is taking all of A and combining it with all of B. So that would be A, B, C, D, E, F. Now remember that U means I'm combining the 2 sets. So when I take A complement union C, I've got to have everything from A complement, F, E, G, H. And then I want to add to it everything that's in C. So let's see, C has A, E, and H. And so the union would be that. Remember that when I have union, I'm combining them. I want everything from both. As opposed to intersection means I want to say what's common to both. Or where they overlap. And so A intersect B, where they overlap, I have C and D. Or up here, if I just were to compare A with B, what do they both have? What do they have in common? C and D. A union B, well, we did A union B, it's A, B, C, D, E, F, but that's not what we want. We want the complement of that. So we want everything outside of A, B, C, D, E, F. And I think that would leave us with H and G. And again, if the union is everything inside, the complement would be everything outside, which would be my H and G.
So anything outside 8 and B.
Right,
Okay.
anything outside of both A combined with B, yes. Then next asks for A union C intersect B. So I'm going to play with my colors here a little bit. A union C is putting A, C together. We want to know, where does that intersect? Oh Lord, what did I just do? I did
Yeah,
A.
you did B and C instead.
Yeah, I did. Okay, but I can get rid of it. Thank you. So what do A and C have in common? And then I want to say, okay, where does that overlap B? And you see, A and C combined overlap with B gives me C, D, E.
And we don't include the F. Okay.
Right. Because it's when we're looking for that intersection, we're looking for where they overlap, what they have in common. And now this last one's tricky. This one, the little n in front is telling me my answer should be a number. So what's the number of things in set A? 4. Remember, if there's a little n in front, your answer should be a number. That was finding our set operations from the given sets, and we can draw a Venn diagram to help us. Next one gives us a Venn diagram, and from the Venn diagram, we want our sets. And so first one is A complement. A is what's inside this loop. Complement is what's outside that loop, which would be 2, 3, 4, 9, 10, 11. Next one's kind of like what we did in the last exercise. You want to know A intersect, well, A is what's outlined in green. We want to see what it has in common with a combination of B and C. B union C is putting these two loops together. And so what's the intersection? Where do those overlap? 1, 6, and 8.
So the easier way would be do the parentheses first.
Yes, easier way would be do the parentheses first. So you could do the parentheses first if you did it pencil and paper. B union C, I apologize, is 1, 2, 3, 4, 6, 8, 11. A is 1, 5, 6, 7, 8. And then when I take the intersection, I'm saying, what do they have in common? And what they have in common is the 1, the 6, and the 8. And so if you wanted to do it without, looking at regions of the diagram, you could go through and do it that way. So this next one asks for B intersect A, and the overlap of B and A is just the 1 and the 6. We want to union it with C. C is the 1, 4, 8, 11. And what we have to remember is when we take the union means put them together. So when I put those two together, I have 1, 6, 4, 8, and 11. Just combining them. Next one I think is a little bit easier. It's asking, what do all three have in common? What's the intersection of all three? And that's 1. Then the next one, going along with, I believe it was Marilyn's suggestion, inside the parentheses, A intersect B. A overlapping B is 1 and 6. Going to combine that with A intersect C. Well, if I look for where A overlaps C, I've got 1 and 8. And so when I put those two together, when I take their union, I get 1, 6, and 8. And then the last one has very little work, but it's supposed to be a make you think question. Inside of A is 5, 6, 7, 8, and 1. And I want to know, what does that have in common with nothing? Do they have anything in common?
No.
So my final answer is nothing or the empty set. Next one, in my labs, there is a question that deals with this. We're going to start with they give you a general Venn diagram. So we've got A, B, C. They have them labeled with Roman numerals, 1, 2, 3, 4, 5, 6, 7, and 8. I think they ask you what regions are in A complement intersect B union C. Then they ask you what regions are in A complement intersect B union A complement intersect C. And then they ask you, are they equal? So they word it a little bit differently than I do. But when we did these in class, we kind of saw that in order to determine if those two were equal, we would have to go through and specify the regions involved. When you do this, it's up to you how much work you show. For this one, if I were to make a list of sets and regions to show my work, I guess I'd want to know what's outside of A. And I guess I'd want to know what's in the combination of B and C. And then I want to know what that intersection is. Inside of A is 1, 2, 4, 5. Outside of A, does everybody see, is 3, 6, 7, and 8. The union C, if I take everything from B and combine it with everything from C, taking their union, I'd have 2, 3, 4, 5, 6, and 7. And so now when I compare those two, they both have intersection in common, 3. They both have 6. And they both have 7. Then for the next one, we already know A complement. I'd probably want to list what's in B, which is 2, 3, 5, 6. And I'd use that to say, what does A complement have in common with B? And so this time, to see what A complement has in common with B, I'm comparing these two. What shows up in both of them? I think they both have 3, and I think they both have 6. Then I might look and see what's inside of C. C is 4, 5, 6, and 7. And then I want to say, hey, what does that have in common with A complement? To find A complement intersect C. And let's see, those both have 4 and 6 and no, I'm sorry. They don't both have 4. A complement doesn't have 4. That's right. They both have 6 and 7. So then when I take the union of those two, A complement intersect B, union A complement intersect C, I'm taking these two and combining them, which gives me 3, 6, and 7. On the left, I have 3, 6, 7. I have, on the right, I have 3, 6, 7. So yes, they are equal.
That problem is time consuming.
Yes, which is why when this was a pencil and paper test, that question was a 10-point question. But in my labs, they're all weighted equally. So in some instances, it benefits you that the easy questions contain the same weight as the hard ones. In other instances, there's, it give or take, but. Yes, and do you see how, again, if you showed me all your work and I realized that you made the same mistake that I did, and over here you just put the 4 in, which made your 2 answers wrong, and your answer was no, I would be able to look at it and say, oh my gosh, they just made that one mistake, and the no was correct for what they did. So I would give you more than half credit because what your answer was correct for the work you showed. And I could understand the work you showed. And so that's the value of putting your work to paper. Okay?
Okay.
Instead, if all I have is a wrong guess, yes or no, with a question like this, if all I have is the wrong guess, yes or no, even if it's right, I'm not going to give you full credit unless I see some work.
Okay. How many questions are on the test?
Give me a minute because I knew the answer for the pencil and paper test, but for my labs test, I don't exactly remember. So I'm going to real quick look at the assignment manager, and in the assignment manager, I am going to look at exam 1 sets, and I'm going to, in there, just list the questions. So you don't see the questions, just what they're on. And so here, looking at the list, it's got 31 questions.
Okay.
And if you notice, like, they give an estimated amount of time, the average amount of time students have spent on each question. And so do you see, most of them are well under a minute. And so I think that the time constraints should not be difficult for anybody. Going back to my assignment manager, because I should have said this and I didn't, although we'll go through this again next class. I think for this test, I'm giving you, because I'm giving the same test to my Tuesday, Thursday classes, Monday, Wednesday, Friday, I'm giving you 75 minutes. So you have a little bit over an hour for it, okay? So 25 says a survey of 1,200 American adults was given to analyze their investments, and it wants you to find, answer these questions. So I would treat this like a survey question. Draw my Venn diagram. I'm sorry, the pen is, there it goes. Sometimes the pen and I are not friends. I apologize. I draw a Venn diagram. I'd have one loop for stocks. I'd have one loop for bonds. Remember, we start with the overlap. There are 300 people that invest in both. There are 550 that invest in bonds. So what number should go here? Does everybody remember?
550, no?
The whole circle is 550.
Oh,
But
so
we
it
have
would
three.
be 200,
250.
250?
In the same way, 650 invested in stocks. So the whole circle should be 650, but we've already got 300. So that's 350. And now if I add those numbers up, 350, 300, and 250, that adds to 900. And the whole thing's supposed to be 1,200. So wouldn't the difference tell me there are 300 people out here?
Oh, the leftover.
The leftovers. And so only stocks, now that I have that diagram drawn, is it easy to see that only stocks is the 350? Or we said was like, and, I take that back. It's not like and, we said or is like the union. And so it's the total of what's in the loops, which was our 900. And not in either would be the complement of that, or our 300.
I was having a hard time with that on the homework.
Is it a little bit better now?
Yeah.
Yeah, you know what? It's reading that sentence. I think it would be tough to answer that question if you didn't draw the picture. And even tougher to answer the next question. It says, a resort took a poll of 350 visitors. The results are so many like to ski, so many like to snowboard, so many like to ice skate. And we're wondering how many people liked a different combination of that information. And I don't think we're going to have enough time to fill in this entire Venn diagram right now, but I'm going to label them ski, board, and ice skate. And does everybody remember we start on the inside? Those that like all of them is 2. And then we work backward through the information. 2 like to snowboard and ice skate. And that overlap has 2 in it already. So this region would have 0. 15 like to ski and ice skate. So this region should have 15, but does everybody see we've got those 2 in there already? So 15 minus 2 leaves 13. 49 like to ski and snowboard. And so this overlap should have 49. There are 2 in there already, so we need 47 more. 57 like the ice skate? Is everybody all right if I look at that ice skate loop now? I have 15 people in it, and it's supposed to contain 57. So that tells me I need 42 more. In the same way, 154 like the snowboard, those people are crazy. And right now I have 49 in there. So subtracting, I'd need 105 more. And 178 like the ski. Right now I have 49, 59, 60, 61, 62 in there. And so subtracting that gives me 116 that just ski.
So you added the 47, the 2, and the 13, right?
Right.
Okay.
And now if I add all of those numbers, I would subtract to get how many do none of them. And once that's filled in, it makes it much easier to answer these questions. And again, in the interest of time, I'm not going to be able to do that. I will go back through and put all of those answers in this afternoon and post it filled in. Now, to describe the shaded region, and I don't think this one's on the test. This was something that I used to put on the in-class test as extra credit. If I ask what's not shaded is C. So what is shaded is C complement. But then I also add that little bit of B back in. So it's taking C complement and adding to it B. Again, that one would be extra credit, and I don't think it's on the test. Next class, the test will not be available until after next class. So go through things, study, do your homework. If you have any questions, ask. Next class, though, we're not going to spend the whole class reviewing. We're going to spend a little bit of time introducing that next section, which I believe is chapter, it's either 10 or 11 that deals with probability. Okay.
Okay.
Now, I'm going to stop sharing. Alan, I think you came in after I took attendance. And Alan, I'm going to ask you to stick around for a minute. I want to talk to you. Is there anybody else who came in after attendance?
I think I did.
Bianca? Yeah, I got you.
Oh, okay.
Okay.
All
All right, thank you.
All right, have a good one. We'll see you guys. Bye-bye.
Bye.
Bye.
Good one.
Alan, are you there? Whoops. Let me stop recording.